Welcome to Chapter 5. We're going to shift gears now and start talking about cost volume profit analysis or CVP analysis. For those of you that have taken economics, you have talked about some of these concepts before. Some of cost behavior, we'll be talking about break-even analysis and things like that, but we will be looking at it from a different perspective. If you haven't taken economics before, don't worry, you're not behind. I'm going to teach you everything you need to know. Now, this chapter does have a lot of formulas and we're going to be doing a lot of calculations. So one of the things I always strongly suggest is that you've got your notes printed out and ready to go so that you can really engage with the content. You'll want to be pausing the video, trying to solve the problems on your own, and then restarting the video and checking. We'll be drawing lots of graphs. Some students also find it helpful to kind of keep a separate sheet of paper nearby and use that as a formula sheet. And then they like to write down all of the formulas, because we're going to have a lot by the end of this chapter, on that one formula sheet, and it makes it a little easier to flip, to have that one sheet there instead of flipping back and forth throughout your notes. So to get started, we're going to talk about how changes in volume affect cost. So CVP analysis, cost volume profit, is looking at how changes in cost and changes in volume affect profit. But before we can get to the profit component, we need to look at how changes in volume affect cost. Now, how they affect cost depends on what type of cost we're talking about. So we've got three basic types of cost: variable, fixed, and mixed, and we're going to go through and define each of those three types and draw those graphs. So a variable cost is a cost that changes in total. So the key is a variable cost varies or changes in total. It is fixed or constant per unit. So a variable cost has the same per unit cost, but the total changes. And a key part of this definition, and I don't have it on the screen, but you'll want to write it down, is that it changes in total as volume changes. Really, you could say this in direct proportion. So what that means is if volume doubles, the total cost will also double. Not almost double, but exactly double. If the volume triples, the total cost will exactly triple. If the total cost quadruples, if the volume quadruples, the total cost will also quadruple. You get the idea, right? So here we have some examples where, remember, Smart Touch Learning, we're making tablet computers. The cost per tablet is $55. No matter how many tablets we produce, the cost is always $55. So the cost per unit is constant. That's one of our clues that it's a variable cost. You'll also notice that when we make 25 tablets, the cost is $13.75. But when we double that to 50 tablets, the cost doubles to $27.50. So that again is our clue that this is a variable cost, because as volume doubles, so does the total cost. So if we were going to graph a variable cost, very important, let's talk about how we draw these graphs in accounting. First of all, we know that there's 4 quadrants. For those, remember back to our algebra and our geometry, if you were to draw a graph up here, there's 4 quadrants, with this one in the upper right-hand corner being quadrant 1, and then quadrant 2, and then quadrant 3, and quadrant 4. We live up here in quadrant 1. We always operate out of quadrant 1. That is because costs are always positive. You can't have negative cost. And production is always positive. You can't have negative production. Now, a variable cost, very important here, a variable cost always starts at 0, 0. So if we are making 0 units, then the total variable cost is 0. Now, one thing that I do want to point out before I get any further is that when we are labeling, when we're drawing our graphs, we want to always label our axes. The x-axis or the horizontal axis is always going to be a quantity of something. In this case, it's the number of tablets produced. It may be the number of minutes that the machine ran. It may be the number of labor hours. It may be the number of dogs washed, but it is always a quantity of something. The y-axis or the vertical axis is always a dollar amount. So in this case, it's the cost of the batteries, which are $55 a piece. It could be the revenue per unit, it could be the profit, but it is always a dollar amount. So if we produce 0 tablet computers, then total variable cost will be 0, so it's always 0. And then notice that it goes up at a straight line. Okay, so thus the direct proportion, it goes up in a straight line. So if we make 1 tablet computer, then the total cost is 55. If we make 2, the total cost is 110, and so on and so forth. Remember that our quick and dirty formula for slope is rise over run. So every time we go up 55, we go over 1, and up 55 and over 1. Therefore, the slope of this line is always equal to the variable cost per unit. Now, VC subscript U is my way that I indicate variable cost per unit, because we're going to talk about variable cost per unit, and then we're going to talk about variable cost in total, and so you got to have a shorthand way to distinguish between the two. So I will write VC little u for VC for variable cost per unit. If I'm talking about variable cost in total, I'll call it VCT. Again, that's just my shorthand that I made up. You're welcome to use it. You're welcome to make up your own. But the slope of this line is always going to be the variable cost per unit, which in this case is 55. But of course, it's not always, it varies, but it's always the variable cost per unit. So remember, your y-intercept is always 0. Your slope is always equal to your variable cost per unit. Now, fixed cost. Fixed costs are costs that do not change as production changes or as volume changes. So again, if we're going to graph this, notice we're in quadrant 1. Our x-axis is still a quantity of something. In this case, it's number of tablets produced. Our y-axis is still a dollar amount. In this case, it's the total fixed cost. And this graph is always just a straight horizontal line. So in this case, no matter how many tablet computers we produce, we're going to spend $13,500 in fixed cost. It doesn't matter if we make 0 units. It doesn't matter if we make 100 units. The fixed cost is $13,500. So a variable cost is a cost that does not change in total. It is fixed in total. Okay, so the total is fixed. Now, on a per unit basis, there is an inverse relationship, meaning the more units we produce, the less it costs per unit. Okay, so think of it like this. Your car payment is a fixed cost. You pay a flat amount regardless of how many hours or miles you drive in a month. So let's say your car payment's $300 a month. If you drive 100 miles that month, then your cost per mile was $3. If you drive 1,000 miles, then your cost per mile was 30 cents. So the more you drive, the less the cost per mile, but the total cost is the same. So here we can see that if we made 25 tablets, our total fixed cost was $13,500, but the cost per unit was $540. If we make 100 tablets, the cost per unit is $135. So there's an inverse relationship. As activity increases, the cost per unit goes down, but the total stays the same. So this is just a graph to kind of refresh our memory. Remember, variable costs vary in total. They're fixed per unit. Fixed costs are fixed in total. They vary per unit. Now, a mixed cost has both a fixed and a variable component, which means that as production increases, total cost will increase also, but it won't increase by a direct amount. It'll increase, but not by exactly. So here, if we look, if we go from 100 minutes, our total cost is 110. But if we double that to 200, our total cost increased, but it did not double. So that's how you can tell the difference in a fixed and a variable cost, in a variable and a mixed cost, is in a variable cost, the total cost will double when production doubles. Now, if we're going to graph a mixed cost, this is an interesting graph, so I want you to listen to me before you try to draw. So keep in mind we need to label our axis. So our x-axis is always a quantity. In this case, that is number of minutes, the quantity of minutes. The y-axis is always a dollar amount. In this case, it's total cost. Now, this graph looks like you took a variable cost graph and you set it on top of a fixed cost graph. So instead of our y-intercept being 0, 0, like it was in a variable cost, our y-intercept is always equal to our fixed cost amount. In this case, that was $100. So your y-intercept is the fixed cost. Now, I want to point out, we rarely talk about fixed cost per unit. Almost exclusively when we're talking about fixed cost in this context, it's in total. So I don't abbreviate my fixed cost with a U or a T. You certainly could, but these are almost always in total. Now, the slope of the line is still going to be your variable cost per unit. So in the data we looked at on the previous slide, our fixed cost was $100. And then for every minute on top of that, we were charged an additional 10 cents. So the slope is still equal to the variable cost per unit. Now, one of the things that I want to point out is this is your line. This is not really a line in this. Okay, it's just drawn there for illustrative purposes, because if we look at our possible activity, there's no way that total cost can ever be less than $100, because even if we made 0 units, we'd have to pay that $100 flat fee. So this line isn't really part of the line. There's only one line here. It's this green line that I've kind of drawn through there. So as you're drawing the graph, you might want to make this one maybe as kind of just dashes or something, or even leave it off altogether. Really, it's just that green line there. Now, in real life, we have a lot of fixed costs. You have a lot of costs that are just fixed. Your rent, your insurance, your property taxes, loan payments, all of those are true fixed cost. Turns out we have very few really, truly variable cost. Even things that we think of as being variable, like your utility bill, your electric bill, things like that, they're not truly variable. If you use 0 kilowatt hours of electricity, your electric bill will not be 0. You pay a flat fee to the electric company just for the privilege of having electricity at your house. So even though we think of electricity as being a variable cost, it's really a mixed cost. So most of those costs that we think of in real life as being variable are really actually mixed cost. So in order to properly analyze those, we need to break those costs into their fixed and variable components. Now, there's a lot of different ways that we could do this. The most sophisticated way to do this is to use linear regression in a statistics package. We're not going to do that in this class. You're welcome. So we're going to do a slightly less sophisticated method of breaking these costs into their fixed and variable components. We're going to use what's called the high-low method. And so the high-low method is going to list, let's say, all of your costs. Maybe let's take our electric bill, for example. Maybe you list all of your electric bills for the last year. You're going to list what your total bill was and how much electricity you used. And then for the high-low method, you're going to pick the highest month, which is the highest bill and the highest usage, and the lowest month, the lowest bill and the lowest month usage. So in this example, we're looking at maintenance cost. And we've got it broken down by quarters. And so we know how much our maintenance cost was each quarter and how many tablet computers we produced each quarter. So we're going to pick our high, which was the third quarter, was our highest month. Notice it was the highest dollar amount and the highest activity. And we're going to pick our lowest, which happened to be the fourth quarter. And again, it is the lowest point for cost and for activity. Now, in real life, it doesn't always work out that your lowest cost is your lowest activity because rates change and things like that. If that happens, you can't use the high-low method. You're going to have to use regression, or you're going to have to use a shorter time span to look at. So the idea with this is, and think back to your algebra and geometry classes, in order to determine the equation of a line, we need to know 2 points. You only need 2 points to make a line. So this is what we're going to do. We've chosen 2 points on this line, the high point and the low point, and we're going to mathematically determine the equation of that line, which will then tell us what the slope of that line is, which is the variable cost per unit, and the y-intercept of that line, which is the fixed cost. And those are the two things that we need to know. So the first step is to calculate the slope of this line using our 2 points, or the variable cost per unit. Now remember, our quick and dirty formula for slope is rise over run. And if you think about it for a minute and you think about our graph, remember the rise, the y-axis, is always dollar amounts. Okay, so the rise portion of this is going to be your high dollar amount minus your low dollar amount. This is the change between your highest cost and your lowest cost. That's the change on the y-axis. Now the run portion is the horizontal portion. This is the change in quantity. So this is going to be your high quantity minus your low quantity. So we're going to just plug that data into our equation and solve for the slope of the line, which is our variable cost per unit. So if I remember correctly, and I just switched the slide so I probably don't remember correctly, but you have the data in your notes in front of you, my high cost was $1,960 and 480 tablets produced. And then my low cost was $1,480 and 240 tablets. So my numerator is going to be the 1960 minus the 1480 divided by the 480 minus the 240. Now remember your order of operations. You need to do the subtraction in the numerator first, then the subtraction in the denominator, and then do your division. Especially if you're plugging this all into a calculator, then you've got to make sure you're using your parentheses. So I see a lot of students make mathematical errors here because we don't follow our order of operations. PEMDAS, or please excuse my dear Aunt Sally, however you learned it. But when we calculate it out mathematically, then we wind up with $2 per tablet. So we know that the variable cost per unit is $2 per tablet, or the slope of our line is 2. Now, the next step is to calculate the fixed cost. Now, remember, this is the y-intercept of the formula. So at this point, you have an option. Okay, we're trying to calculate the y-intercept. So think through this with me for a second. Remember, the equation of a line that most of us learned is y equals mx plus b, right? Where y is your total, m is your slope, and b is your y-intercept. So essentially, we are trying to solve for b. So we could rearrange this equation to say we could subtract mx from both sides, and then I could rearrange it to say b, which is the y-intercept, is equal to y minus mx. Okay. Or I could plug in accounting terms for this. Remember, b, the y-intercept, is fixed cost. Fixed cost is equal to y is our total, so in this case this would be total cost minus m, which is our slope, our variable cost per unit, times X is just our variable. In this case, our variable is the quantity produced. So I like to use Q instead of X. You can use whatever variable you want, but I like to use Q instead of X. So if I'm trying to solve for the y-intercept or the fixed cost, I'm going to take the total cost. It doesn't matter if it's the high cost or the low cost. Either one will work. In fact, you can do it with both and check your answer, and it should be the same, assuming you didn't have to do any rounding on the variable cost. So I can take my high cost minus my variable cost per unit, which is 2, multiplied by my high quantity. Or I could do it using the low. So I could say my low cost, my total cost at the low point, minus 2 times the low quantity is going to give me the fixed cost. Now the thing you can't do is use the high cost and the low quantity, or the low cost and the high quantity. You can't mix and match. You got to choose one. So I'm going to go ahead and do it using the high. So I took 1960, which is my high cost, minus $2 per tablet, which is my variable cost per unit, times the high quantity. That gives me 1960 minus 960, or fixed cost of $1,000. Again, we could do it the same way using the low. So you plug your low cost in, minus $2 times the low quantity, you should come out with exactly $1,000. So now I'm going to use all of this data to create my equation of a line. So again, remember our equation of a line we know is y equals mx plus b, but we can just restate this by saying y is total cost, m is the variable cost per unit, x is your variable. In this case, it's your number of units, so I like to call it Q, but you could call it X if you prefer. And B is your fixed cost. So we're going to plug in what we know now, and we can use this equation to help us estimate what the total cost will be at any given point. So I know that the variable cost per unit is 2, and I know the fixed cost is 1,000, so I could say total cost is $2 times the number of tablets plus 1,000. Or I could say total cost is equal to 2Q plus 1,000. So now again, I can use this equation to say, well, what do I estimate the total cost would be if I made 560 tablets? And I can plug 560 in for Q and solve for the total cost. We'll use this exact equation in the next chapter, in chapter 6, when we get to budgeting. And we're trying to create our budget for next year. We have to estimate what our total cost will be. Well, now we can use this equation. We can estimate how many tablets we're going to produce, plug that in, and estimate what our total manufacturing cost will be. So let's use this as a practice to estimate what our cost would be if we made 400 tablets. So here's one of those places where you want to pause the video, try to work it out on your own, and then come back and restart the video and check your answer and listen to the explanation. So when I plug 2 in for Q in that equation up there, I get 1,800. So if I made 400 tablets, I would estimate that the total cost would be approximately $1,800. Not an exact number, but it's certainly an estimate, and a pretty good estimate. Now, one last thing to talk about before we move on is the relevant range. So when we talk about a cost being fixed or variable, we mean within a relevant range. We don't mean from 0 to infinity. We don't mean forever and ever and ever. So I always use the example of, I used to live in an apartment. And when I first moved into the apartment, I signed a 1-year lease. So I'm going to draw my graph up here. Label my axes. I signed a 1-year lease, so my rent was fixed for 1 year. So my graph of my rent for 1 year looked like this. But when I went back in to sign my lease on year 2, guess what? They'd gone up on the rent. So for the second year, my lease looked like that. So it was still fixed, but it was only fixed over that set period of time. Since I had moved in, it had varied a bit. When I went in year 3 and signed my lease again, guess what? They'd gone up on the rent again. So in any given point in time, if I were to look at it from just this window, my rent was fixed, or in just this window, my rent was fixed, but over time, it was variable. So we're talking about, when we talk about whether a cost is fixed and variable, we mean within this relevant range, because most of us don't operate from zero to infinity tablets. There's things like economies of scale, there's discounts if you reach certain quantities, there's things like that. So we're just talking about within this set period of time or level of productivity that these costs are fixed or these costs are variable.